Today we'll be talking about the dependent samples t-test or the paired sample t-test. It is another relatively straightforward test. It will be basically in the same lines. The difference is you're looking at a pre and a post test. This would be a true experimental test where, let's say, you were testing an athlete's mile run, and you do it at the beginning of the semester and the end of the semester. It will give you a lot of data in terms of what the mean is, how the means compare from the beginning of the season to the end of the season. Again, we're looking at the mean, the difference in the mean. Is there a large difference in the mean, or is there a small difference in the mean? There is no male-female. There's no nothing. It's based on 2 scores. So to give you an idea of where you're going in this week, there is within this there is an example, one that's done on caffeine. We have another one done on oxygen level, and then we have another one on volleyball serving. Okay, the example is your first write-up. That is for your homework. The oxygen level is your actual homework, and the volleyball is what you're going to put into your paper. Okay, your project. So there's 3 different levels. You have the example, you have your homework, and then the last one for your project. So as you focus on this, know that they are going to look exactly the same, just as they did with the independent samples and the one sample t-test. Follow the example to the T, and you'll have no problem with this week. Your analysis for each of them will be very simple, and I'll be able to show that to you in the example. It's very straightforward, numbers based in this. You still have your significance, you still have everything else, but it's numbers based. It's based on the mean. Who had the higher mean, before or after? There's no standard formulation for the calculation of T, and assumes there's no correlation between the groups. So we will be also in this one, we will be reverting back to correlation for a significance level to see if it's actually correlated or not. Okay, this is a t-test where we're testing groups of participants twice in a session in a pre and post test comparison. The definition of this assumes the relationship or correlation exists between the scores and person's score on a post test, partially dependent on his or her pre-test score. Basically saying, I run the mile in 4 minutes the first time, I run the mile in 3 minutes the second time. Everybody else does the same thing. We're going to have a great score, but we also want to see if it's significant enough compared to the mean. This is the example. The example is caffeine versus no caffeine and how many hours are slept. So those are your variables. You have caffeine on one side and no caffeine on the other. This is not a pre-test, post-test. This is comparing 2, okay? 2 different variables. The hours of sleep are noted here under the participants. At this point, you need to open the output called caffeine, okay? It also can be named example, okay? I'm going to be pulling up the data in a second. So you can see on one side the participants' hours, and on the caffeine, no caffeine side, I can see the participants' hours of sleep. So if I look at this, I can then actually take a moment and just visually look at it and say, okay, visually, since the numbers are there, the people with no caffeine are getting more sleep. But it doesn't tell you enough. It doesn't tell you the mean. It doesn't tell you how far the actual mean is away from each other. And that's the data you need in statistics. I can say, okay, no caffeine gets more sleep. Of course, there are extenuating variables that are not there. Those variables that can change in this. We don't know how much caffeine they're drinking on the one side. There's no level given. There's nothing. If we were writing a report, we would have to give all that stuff. We also don't know if the caffeine are secretly getting caffeine behind. So there's lots of factors that go into this. But for this one, we're talking about caffeine versus no caffeine. Now here is the output that you have, okay? Everything that you're going to be doing here is right in front of you, okay? You can see the mean of the caffeine for the hours slept is 5.40. You can see the no caffeine is 9.40. There were 5 participants and the standard deviation was equal at 1.14. So you can go either way, 1.14 past 940 or back from there. So it would be 10.54 and 6.54, and you go negative on the other side. It's the middle one that actually focuses on what is our correlation. Going back a couple weeks ago when we did correlations, remember we talked about positive and negative are the same. So this is a positive 0.038. Well, it's really close to 0. Okay, so when we're it's almost a perfect correlation. Okay, the significance is high. It's non-significant, but it's not highly correlated. Okay, it means because the difference between the means are very large. So this would be a very minimal or very slight correlation, positive correlation. Okay, down here at the bottom you can see the mean is the mean here for the paired differences is negative 4.00. That relates to the mean up at the top here. This mean right here of 4.00 equates very simply to 9.40 minus 5.40. Okay, so that's that. The standard deviation is 1.58, which is a little larger than this, but that's because now they're pairing the differences between the two. This is the t value. You see the t right here. This is the df, is 4. That would be 5n, which will be the 5, minus 1 equals 4. And the significance is 0.005. Remember, above 0.05 is non-significant. Below is significant. So this is 0.005, so this would be significant. So here is the write-up. There was a significant difference in the scores for caffeine. You put the mean and the standard deviation, just like you have before. Remember, the M and the SD are both italicized. There's spaces between the equal signs. And no caffeine, mean and standard deviation. Because remember, you have 2. You've got to report both. And then you'll see the T value here. T is 4. This is the DF. Okay? Equals negative 5.66, which is the T value. And then P, italicized, is less than 0.05. A slight non-significant positive correlation was reported at R, italicized, equals 0.40, okay? And then P is greater than 0.05, okay? This was rounded up to 0.04. P is greater than 0.05. The results suggested caffeine had an effect when compared to hours slept. This is where the conclusion starts to roll in, okay? We already knew that caffeine has an effect. So we're really looking at does caffeine have an effect on the number of hours slept? Well, be it that they're negative 4 in the mean differences, then there is an effect between the two. Plus, your significance level on the bottom line of your output points to the fact that the significance shows that there is an effect. And this is the entire write-up, okay? The results suggested caffeine had an effect when compared to hours slept. Therefore, your concluding statement, comma, the results suggested when humans consume caffeine, the number of hours they slept decreases. So you're going back to that, if you were to draw a scatter plot again, you would see that there was a decrease in sleep from caffeine to non-caffeine. And there's the concluding statement again. Okay, now I may have said at the beginning that it's going to be oxygen, but the volleyball one is your homework. The volleyball one is your homework. So, understanding this, you're looking at volleyball scores from volleyball serving scores from preseason to postseason. Okay, you're looking at whether the players improved over the season. So each of them served 25 serves. Okay, preseason scores on the left, the postseason scores on the right. You can already make an analysis of whether they improved or not just from there, but you don't know how much, and that's what you're going to do. So you're going to pull down the data, the output called volleyball. Okay, you're going to take the write-up that we did in the example, and you're going to model it after that. So taking all the data in, looking at the data that's on that page, filling in the blanks, and then doing an analysis the same way. Remember, they served 25 serves at the beginning of the season, 25 serves at the end of the season, and they compared them. So if you go back to the example and listen to the example again, then you're going to be able to easily be able to analyze this one. And this is for your project. That's the oxygen level. Do a cursory look to the pre-test and the post-test. It's a maximal oxygen consumption before and after a 10-week training program. Okay, so they trained for the 10 weeks at the beginning. They did the oxygen at the beginning and maximum oxygen in the end. Now you have your scores. Okay, and this is all you have to do this week. So if you have any questions, feel free to call me. But that beginning, if you'd follow that and do it for each of them. This one ends up in your project under paired samples. Okay, the other one gets turned in, only the write-up, online text online, and then you have the example. You can put all three of them in there, and I'll check them all and give them back to you, or just do the homework and put this one in your project. That's the end of this week.